Okay, hello everybody. Today I'm going to explain what I'm trying to do over here. I'm trying to build a vertical generator, and we see the assembly quite advanced, but I can explain exactly what I've done. I've made 9 coils. I've used 12 gauge wire, which is about 20 ampere, and I've wound them to give me 60 turns per coil. And I'm making 3 phases, so every 3 coils is going to be 1 phase. And you can see over here, if you get a little closer, you can see that they've been soldered. I've twisted them. I've used silver solder, and then I put some nail polish right over the joint, just as an extra protection. And this is the starts, and these are going to be the finish. The reason is I didn't do a delta or a Y configuration. I decided to keep them on the outside so that I can wire them out externally and change the configuration at any given time. These are the what I've used to make these connections is, believe it or not, they're brass. They're for toilet bowls. They hold the toilet bowl together. Hang on, I'll get you one. I'll show you. There are these master plumbers with the bolts, the nuts, sorry. And what I did, I put a bit of Vaseline and I dropped them in. After, of course, I've soldered. I put a nut. If you get it a little closer, Frank, you can see the from here, from this angle here, maybe you can show them Yeah, just to show you, I soldered it underneath. I first had to burn off the protective coating on the wire. It's very high temperature stuff, so I used a torch. I burnt it off, then I cleaned it with sandpaper, and then I wound it around tight. I put a nut and I soldered it. Made a nice job, actually, believe it or not. And now they're bolted in place. You can see underneath they're bolted so that they're in exactly the position I want. Eventually, when I'm going to take this mold apart, after I finish with the resin, and they'll be exactly in the right position. And I'm also going to have exposed a big washer like this, so that my terminal connections are going to be very good. And I already did a resistance, and I got the 4 ohms at any given phase, so there's no resistance. These things are well wired. I kept a little gap in the middle here. I'm keeping a big gap on the outside. Now if you look at this jig, I pre-drilled it, I pre-designed it, and I also jigsawed it. I also put like a Teflon tape around the perimeter here, so that after I pour, it should come apart easily. Also, there's wax, car wax on all the components here. At the bottom underneath, I got some fiberglass cloth. So after I poured, the bottom half already has it. I'm going to lift it up, of course. I can lift this up if I want, and make sure there's no air bubbles. And this is just to give you an idea of the type of coil I used. You know, after I've done it, I've made a jig to turn it so that the wires are really close knit to avoid space waste, and also more efficient. And you can look at the inner diameter here. It's exactly the shape of a magnet as it passes over. So here's the drawing. If you want to see the drawing, the pre-drawing I used to make it. I used just regular maths, and I took the diameter of my rotor, and actually the rotors, I'll show you the rotors. These are the rotors I'm using. Believe it or not, thanks to Guy Auto Parts next to my house. The guy, very good guy, very helpful. We went through his inventory to find rotors that would do a good job, and my goal was to find the rotor with the most outer diameter, because of course the more outer the magnets are, the faster the speed of the magnets running over the coils, and of course more power. So we were able to find these rotors off Impala 2005, and they're 12-inch diameter. And thanks to, of course, Guy Auto Parts again, he let me use his lathe in the back. And what I did is I machined them. I took off 100 thou of material here, and I left this outer perimeter here, so that the magnets, when they're going to sit here, they're going to sit against this outer edge, and they'll be able to hold themselves in. The centrifugal force will not make these magnets go flying out. Then once I had them machined, I brought them to a place that does plating, Zinc and Plating Montreal. Thanks to them, they zinced them for me. Actually, they nickel plated them and then they zinced them. So my goal is these things are going to be corrosion resistant because of our Canadian winters. I'm building this thing to last a long time and not be eaten away by the weather. I had to use a weight scale because on the coils it was hard to get exactly 60 windings per because of the thickness of the wire. I mean, 12 gauge wire is extremely thick. It's thick to bend, you can see it, and to get them exactly. And those ones there, this one here is the first prototype I did, and this one is 5/8 thick, and it has 6 times 8, 48 windings. I was able to put 8 windings this way and 6 this way, so 48 windings. Then I found out through my drawing that I could have more space. If you look, because there's 40 degrees in between each coil. The magnets are 30 degrees apart, but the coils, there's only 9 coils, so 9 coils gives you 9 times 4 is 36, 360 degrees in a circle. Whoop, drop that. But the magnets are going to be 30 degrees apart. So because I put it on my drawing, I noticed, hey, I got more room here. So I went and find exactly how much room I have. You can see it over here. This is how much extra room I had. So I decided to do another type of coil. I decided I can put more windings this way until they touch each other. So what I did is I changed it around and I went 6 coils thick and 10 windings around, which gave me 60 windings per coil of 12 gauge. And that fits perfectly this way. Also, because I reduced the from 8 to 6, I was able to change my thickness of my stator. My stator is going to be 5/8 thick. The magnets equivalent are about 1/2 inch plus a bit of epoxy and fiberglass. I have plenty of room with 1/8 to make sure that it's a level 1/8 thick. 5/8 thickness. Now, the reason 5/8 is better than this one. This one was like 5/8 originally, and it was going to go up to 3/4, 750. I'm thinking in thous here, but 3/4 plus the gap between the magnets. The closer you can get, the magnets become inversely proportional in strength. So the closer we can get these magnets, the more power you're going to be able to extract from these magnets. I'm using magnets that are 2 inches by 1 inch by 1/2 inch thick, and they're N50, and they produce 82 pounds of pull each magnet. So I'm going to have a lot of strength there for the condensity of this unit. So where are we now? This is like the first, I'm in the beginning stages. I mean, my pieces are falling together. I still haven't determined my rotor or anything, but I have made the base. If you want to see the base, again, we go back to Impala. I'm using checkered plate, 3/16 thick aluminum, T6 hardness. This was thanks to my buddy Jose. He donated this piece to me. He's in the industry, and I told him what I wanted to do, and being an old friend, he gave me this piece. Now, the actual bearing, I'm using again. I stuck with GM. They're the cheaper parts, but this is it's a bearing that's not adjustable. Like some people use the ones off a trailer where you got a castle nut and you can adjust the tension so there's less tension. This one has a little bit of tension on it. I know it does. But with time, it's going to loosen itself up. Also, it's no maintenance bearing. This thing should be on my roof 25 years. That's what I'm aiming for with the quality of materials I'm using. Now, this is going to go with different types. I'm going to use like these adjustable rod. This is threaded rod where I can adjust it. These are going to go through here. We're going to get one rotor at the bottom, the stator in the middle, and the stator, if you notice over here, I got these cutouts, which are going to use similar. I'm going to use the smaller ones. These are to hold the magnets together. I'm using 5 1/2 inch 13 thread. And to hold the stator in place, of course, we're going to have once I pull this out of the cast, I'm not sure yet if I'm going to pre-drill these holes and put an insert inside, or I'm going to drill it after, because I have plenty of room to drill it after with no interference of it going anywhere near the wires. And so I can adjust the height of the stator being fixed to the base of that I'm preparing. So the stator can be adjusted with any clearance I decide between the two rotors that are rotating. Now, I'm at a point where heat is an important detriment to these units. From what I read, that heat is a problem, and especially if it's going to be on a roof in a Canadian hot summer. I mean, our winters are brutal, but our summers are very hot and humid too. And these units can very well easily heat up if I got a very windy day. So now I'm at a point of contemplating using liquid cooled on the outer perimeter. I made this coil wire. I cut out the areas here where it's going to be inside the mold. After I take the mold out, these units will be sticking out where I can flare them, or I can solder some connectors. And I was thinking of it going through a small radiator of a car for the heating system, something not too big, and using the actual wind going through there, liquid cooled with antifreeze inside. I should be able to bring the temperature down. Now I'm at a point where I'm not sure yet, because I am using coil around the perimeter of these coils, and these coils produce EMF energy, and I'm not sure yet. I didn't research it enough. The idea came to me this morning, and I put it in place anyway, and I'm going to research it in case the electromagnetic force of the wires or the frequencies that they're giving out, it might interfere, or maybe yet, I'm not sure yet, but this copper tube might actually absorb some of the frequency. So that's where I am right now. Anti-skid. Yeah, also anti-skid. The reason I use this unit, the guy gave me the choice if I wanted the one with anti-skid for a Impala 2005. And I told him I prefer the one with the anti-skid, because this here has an impulse every revolution, so I'll be able to determine the speed of the rotor on my roof without me ever going up there. So I chose the one with the anti-skid. I'm not sure yet how I'm going to use it, because I didn't research the impulse it gives, but I will figure it out later and establish some kind of system that will be able to tell me the RPMs of the unit. What else? Anything else I should mention? Well, I will have a follow-up video when I advance this project a little further.